Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome to another computer science lecture. Today we would be discussing section 3.2 input and output devices, whereas if you're following the old syllabus, then this is chapter number 5 of the old syllabus. Now this section or this chapter is basically divided into three parts: input devices, output devices, and monitor and control system. Whereas in the new syllabus they have distributed this 3.2 section into three parts: input devices, output devices, and sensors, because they have increased the number of sensors. So that being said, let's start our lecture. So first of all, we are going to discuss input devices. Input devices are those devices which are used to input data or give commands to a computer system, whereas output devices are devices which give an output or a result from computer to the user. So first of all, in the input devices section we have scanners. Now the first type, there are two types of a scanner, and the first type is 2D scanners. What they do, they convert hard copy documents into an image file or into digital format. They are commonly used in offices. Documents scanned by a scanner can be converted into editable text files by the use of OCR, optical character recognition software. Examples: passport reading scanners at airport, 2D barcode scanners at supermarkets, etc. This is what an office or school scanner looks like. Now, how does a scanner works? The document is placed on the glass plate and the cover is closed. This is the cover. This is a document, and below it is a glass plate or a glass screen. The document or whatever is to be scanned is put on the glass plate and the cover is closed. A lamp is used to illuminate the document. The scan head is moved slowly across the document. Light which reflects off the document is reflected by mirrors which pass through a lens and falls onto a CCD array. CCD stands for charged coupled device, which converts photons or which converts light into electric signals. The analog electrical signals are then changed to digital values by an ADC, analog to digital converter. The digital values are then sent to the computer, and with the help of scanner driver software they are interpreted as an image file which can be stored or processed by an OCR algorithm to produce editable text file. For example, if it is a text document which you are scanning, you can convert it into a Word file which you can edit. Next we have 3D scanners. They scan solid objects and convert them into 3D images or 3D models by taking images from multiple angles and combining them to form a single 3D image. 3D images or models can be used with CAD software. CAD stands for computer aided design, or 3D printers. For example, CT, computed tomography scanners, which are used in hospitals. CT scanners use X-rays. MRI, magnetic resonance imaging machines, again they are used in hospitals and they use radio waves. Smaller handheld or portable 3D scanners are also available in market for home or office use. Sometimes people use them in their workshops, or especially those workshops where they work on 3D printers and 3D models. Mostly used by designers and artists, sculptors, etc. This is what an MRI or a CT scan machine looks like, and this is a portable 3D scanner. Next we have barcode or barcode reader. This is what a barcode looks like. Combination of black lines over white background. Barcode consists of a set of black and white lines of varying length, or you can say varying thickness. It's better to say varying thickness, which can represent numbers from 0 to 9. Barcode readers use red lasers to read barcode lines, which are then interpreted as 0 and 1's binary codes. Once the barcode is read, it is searched up in the stock database, and name and price and other details of item is sent back to the POS computer, which adds them to the customer bill. Number of stock is reduced by 1 each time the barcode is read. This is what a handheld barcode scanner looks like. How does a barcode scanner reads a barcode, or how does a barcode scanner works? The product is swapped onto barcode reader or is scanned with a handheld barcode scanner. A red laser reads the barcode. Barcode is made up of black and white lines. The red laser is reflected by each line differently. White lines reflect laser completely while black lines absorb it, reflecting very little or no light. A sensor in the scanner detects the reflected light and a pattern is generated. For example, 3 black, 2 white, 1 black and 1 white line would generate the pattern as D, 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 L, L, D, L, D for dark, L for light. This pattern is then converted into binary in such a way that each dark line represents a 1, whereas each white line is converted into a 0. So this would become 1, 1, 1, 0, 0, 1, 0. Fine, and whatever the binary pattern that is saved is then converted into a barcode number using binary to denary conversion. What happens after a barcode is read, or how does a barcode helps in automatic stock control? After the barcode is read and a barcode number has been generated, this number is looked up into the stock database. This number is the key field in stock database. After the number is found, the stock item record is looked up and details like item name, price, expiry, etc. are sent back to POS or checkout counter. The number of stock item in the record is reduced by 1 each time a barcode is read. This new value is immediately updated in the stock database. The update stock number is compared with restock or reorder level, which is pre-stored in the system. If it is less than or equal to this value, an automatic order is sent to the concerned vendor and a flag is added to this record, so the next time barcode is read, another reorder would not be placed. When new items arrive, the flag is removed. Advantages of barcode: to customer, easier and faster to change price of items, shortened checkout time or checkout queues, itemized bill generated, errors in charging customers are reduced, better track of sale by date. So food should be fresher, as you can look on the bill and see at what date you purchase some dairy or some fresh grocery item, and you would know that the food would be fresher if the bill is of a nearer date. To management, more up-to-date sales chart. Because of barcode, everything is computerized, so the manager can see sales chart anytime. Automatic stock control, as we discussed here. Reduction of cost and time, as not each item on shelf needs to be price tagged. Most of the companies print barcode on their items or products, so you do not need to label them. You just need to make an entry into your stock database. Much easier and faster to change price of stock, as you do not need to label each and every item. You simply, if a price is changed, you simply need to log into the database and you simply need to edit the price column, and that updated price would instantly be applied to the whole stock. It is possible to check customer buying habits. Disadvantages: can only hold up to 30 digits of information. High initial cost needed to set up POS, point of sale. Some products are so small that labeling them with barcode is difficult. For example, rings, for example, earrings, or similar jewelry items and some kitchen items, etc. These two questions are important related to barcode, which we have already discussed. Next we have is QR code or quick response code, which looks something like this. It is an advanced or updated form of barcode, and it is made up of a matrix of black squares on a white background. QR codes can be easily scanned by cell phones and can include website links or special promotions. Advantages: can hold up to 7,000 words. No need to type a website URL. Scanning of a QR code can automatically take you to a web link, and it is an effective method of advertising. Disadvantages: a special app is needed on cell phone to comprehend QR codes. Although since the Android version 11 and afterwards, they have included a built-in QR and barcode reader in the with the default Android applications. QR codes can be laced with malware or hacking codes, which upon scanning can hack the user's phone. How is a QR read? How is data stored in QR code? So the answer is the same as this one. How barcode is read? Just that instead of black and white lines, you would say that there is a matrix of black squares on white background. The rest of the detail is pretty much the same. Now this is something new there, which was not in the previous syllabus, but it is in the new updated syllabus. Frame QR codes. Newer QR codes have been developed which include a canvas area in the middle, so a logo or advertising image can be added. Software for creating such codes aren't available for free. For example, look at this example. They have made a QR code with the company's logo in between, and here is the canvas area. It can even be in different shapes, like there is the canvas area in triangular shape, circular shape, star shape, where you can put on your logos. Softwares for generating these codes are not available for free, whereas the normal QR or barcode you can generate for free using different softwares or online tools. Barcode versus QR code. Barcode can hold up 30 characters only. Acha, just remember, barcode can only hold numerical characters, whereas QR can hold up to 7,000 characters. Alphanumeric characters means it can include special characters. It can include alphabets and numbers as well. QR codes can easily be scanned by cell phone, whereas scanning barcodes using cell phone can be troublesome, especially if the barcode is a little long. QR codes can contain clickable, redirectable web links, whereas barcode can only hold numerical data or numbers. Next we have digital cameras. They are used to take quick high quality pictures that can be transferred to a computer via USB cable. Working of a DSLR or digital single lens recording camera. A DSLR camera works by use of a reflex mirror or prism that reflects light into the optical viewfinder, allowing the photographer to capture the image they are seeing in front of them. Okay, this point is just for your understanding. You don't really need to write it if a question comes in the paper. You can directly start from here, that light passes through the lens and is reflected off a mirror or prism inside the camera body. The mirror moves when the shutter is released, opening up a path to millions of imaging sensors for the light. These sensors act as photodiodes. They are CCDs or charged coupled devices which convert light into electricity, and that electric signals are then converted by the microprocessor of the camera into digital format. Each sensor acts as one pixel, and the resultant electric signals are then passed through an ADC which transform it into a digital image array. Most cameras convert each pixel into 24-bit RGB code containing information about color shades and brightness. Quality of image depends upon how many sensors are used to capture image, quality of lens and sensor array, as well as the format in which image is stored. RAW file or JPG. RAW file is usually bitmap format. Advantages: no need to manage a film in camera, picture ready to be printed almost instantly, and you can also write it as picture is available to be previewed almost instantly. This is what the inside of a DSLR camera looks like. This is a diagram and this is a sliced image of a DSLR camera. You don't need to remember the diagram. This is just for your understanding. No need to buy separate cameras. At cell phones come equipped with them. There are up to around 60 megapixel camera is available in cell phones. I'm talking about normal cameras and not ridiculously expensive cameras, cell phones. Disadvantages: huge memory size needed to store raw uncompressed photos taken by a digital camera. The raw image which is captured by a DSLR is of about 25 to 45 MB per file. So for saving it, we convert it into JPG format so that some space can be saved, but raw files take up a lot of memory. Professional digital cameras, DSLRs, are very costly. One camera would cost you at least 1 lakh. Cell phone cameras lack good quality lenses and high memory space. So these are the disadvantages. And moving on, the next input device we have are keyboards. What happens on a keyboard that whenever a key is pressed on a keyboard or keypad, an electronic circuit is completed. Below the key there is a space between the wire or the circuit and the key, and when the key is pressed, the both wires meet and a circuit is completed, which produce a unique signal. This signal is converted into binary, which represents the value of key pressed in ASCII or in binary. By comparing this value with an stored index, the processor knows which character key has been pressed. For example, when you press A, so the value for A is 65. So a signal in binary that has the value 65 is generated and it is sent to the microprocessor. So the microprocessor knows that you have pressed the value A on your keyboard. Advantages: the most basic and most common input device to input textual data into a computer system. It is the easiest way of data entry. It is available on phones, tablets, computers, laptops, even ATM machines and many other electronic devices. Disadvantages: it can cause ergonomic issues such as RSI, repetitive strain injury. It is a pain in the wrist, eye strain, back pain, and carpal tunnel syndrome, CTS. Again, that is a pain near the wrist of a person. If you use keyboard for more than 6 hours daily, then you are going to have either RSI or either CTS, repetitive strain injury, or carpal tunnel syndrome, which is basically a pain in different veins or different muscles of your wrist. More prone to errors during typing, and it is a slow method of data entry. For avoiding RSI, you can use ergonomic keyboards. Pointing devices or mouse, they include optical mouse, mechanical mouse, trackball, or touchpad. Usually on laptops we have touchpads, whereas on other devices we have a touch screen or a optical mouse. To detect movement, an optical mouse uses a light source, a photo detector, and a digital signal processor. First, the light source produces light that shines out onto the surface. The light is reflected back and picked up by the sensor, forming an image of the local surface. Thousands of images are taken every second by the sensor, and these images are sent to the digital signal processor or DSP for analysis. The DSP compares these images to determine whether the mouse is moved in what direction and at what speed. These information is then sent to the computer through wire or wireless receiver, which updates the position of cursor on the screen accordingly. This is the internal diagram of a mouse. Again, this is just for your understanding. You don't need to learn or label it. There is a laser beneath your mouse. Your optical mouse it is shown on the surface is reflected back, and it is then it passes through a lens, and it is then what you can say detected by the CMOS IC, and then the signal is sent to this DSP chip, which decides in what direction and at what speed the mouse has moved. Advantages: it is the most common type of pointing device. Many designs consist of a wheel to allow rapid scrolling. As you might see over here, this is very useful in scrolling. Use of a trackball can prevent a user from RSI. Disadvantages: often require a mouse mat, as mouse can't iterate well on some surfaces. Mouse requires an area of desk space to allow movement. However, this is not a problem in touchpad. Next input device we have is a microphone. It is used to input sounds in a computer for voice call, voice over text, voice over speech recognition, voice recognition, etc. Now there are two applications of input of microphones: voice recognition and speech recognition. Before we discuss them, let's see how a mouse works. Sound produces waves in the air. These ears strike a cone, which are a diaphragm behind the cone, and when these waves collide with the diaphragm moves, which is connected with a coil of wire wrapped around a magnet. When the coil of wire moves inside the magnetic field, an electrical signal is produced in these wires. That signal is then sent to an ADC, analog to digital converter, which converts it into digital form and sent to the microprocessor for storing or processing. And in this way the sound is captured by a microphone. Now coming back to our topic, voice recognition. The computer detects user's voice and converts it into digital wave pattern, which is then compared with pre-stored sample to identify the person. This is usually used in security systems, where you have to stand in front of a closed door or a locked door, and you need to say some specific keywords. The computer records your voice, converts it into a digital pattern, and then compares it with the pre-stored value and decides you are the authorized person. If you are the authorized person, if your voice matches the stored value, then the door opens, otherwise it stays locked. This is used in security systems. Only a few key phrases can be stored or recognized by the system. Next we have is the speech recognition, where the user's words are inputted through microphone and are converted into digital signals, which are then broken into phonemes or phonics. These phonemes are then compared with words stored in built-in direct dictionary to recognize the words spoken and display it on screen. Just like Siri on iPhone, whatever you speak, the Siri is able to understand it by using speech recognition and respond. Or Google Assistant on Android, like if you say open browser, the Google Assistant understands it and opens the browser for you. This system is very complex and errors are likely to happen most of the time, as each person has slightly different accent. These systems are often used by disabled persons to communicate with computer. Okay, so that's it for today's lecture. I'll see you guys in the next video and we'll continue with input devices. Take care. Allah Hafiz.